These notes are about factoring non-monic quadratics. A non-monic quadratic is a quadratic where the a value, or the lead coefficient, the coefficient of the x squared term, is not equal to 1. So first we're going to start off actually with a monic quadratic, just for a quick recall. Our goal right here is to factor d squared minus 4d plus 3. So instead of x's, I use d's. Just to recall, we're looking for two numbers that multiply to 3 and add to negative 4. And if you watched that last video, we did a bunch of these. Those two numbers would be negative 3 and negative 1. So that's how we would factor something that looked like that. It's important to be super comfortable with those because we're going to kick it up a notch when now a is not equal to 1. Like this here, factor 25x squared minus 20x plus 3. This looks a little scary because a now is 25. Our lead coefficient is 25. But there's something actually kind of nice about this quadratic, and you might notice that we can write this in terms of a 5x. Here's what I mean. The quantity 5x squared, 5x times 5x, that's the same as 25x squared. And 20x is the same as 4 times 5x. So even though it looked a little scary, if you sort of break it down and look at the structure here, we can really see these 5x pieces embedded. So let me use that triangle as a placeholder for that chunk of 5x. Instead of calling it 5x squared, let me just call it triangle squared. Minus 4 times 5x minus 4 times triangle plus 3. Wait a second, instead of triangle, if you just imagine that that's like a D or some sort of, placeholder for that whole chunk, we can factor this now. We've turned it into something that looks monic. It looks like that lead coefficient is now 1. It's just instead of factoring it with x's, we're calling the 5x this triangle piece. But now it looks the same as the one that we saw on the page before. We need two numbers that multiply to 3 and add to negative 4. Those two numbers, of course, are negative 3 and negative 1. Notice I'm using this triangle just as a placeholder because I can factor easily with triangle. Don't forget what triangle stood for, though. All the way back here, we let our triangle stand for the 5x. Our chunk that we were talking about was a 5x. So now all we have to do is go back and put that 5x in for where the triangle was holding its place. 5x minus 3 times 5x minus 1. We've factored it. The quadratic in black started off with a 25x squared, and if you imagine multiplying out 5x minus 3 times 5x minus 1, we will get a 25x squared to begin with. If you multiply this out, you'll see we do get 25x squared minus 20x plus 3. We were smart about how we broke it apart, and we made it look easier. We made it into something with a simpler structure that we could factor, and then we replaced back into that all the way at the end. So that's all well and good for ones where, that just kind of magically works out. But what about something like this? 2x squared minus 5x minus 3. The other one was kind of nice because we had that 25x squared, and I know that that easily breaks into 5x times 5x. But now this 2 out front is not a perfect square. Well, what do you wish it was? I don't know about you, but I wish it was a 4x squared, because then we could break it into a 2x times a 2x. Well, let's turn it into a 4x squared by multiplying this by 2. I want to turn that first term into a perfect square. So instead of a 2x squared, I'd like to call it a 4x squared. We have to multiply through by 2, and that's actually not legal. I can't just multiply by 2. Well, don't worry, we're going to multiply by 2 now, and then we have to remember that we did that, so that at the end we can divide by 2. And our work along the way is going to be easier because of that multiplication by 2. Let's see what we get when we multiply by 2. 4x squared minus 10x minus 6. I multiplied each term by 2. Now we can do something similar as to what we did on the previous slide. We can call this 2x the quantity squared minus 5 times 2x minus 6. Because we changed what it looks like, we can now rewrite this in terms of sort of smaller chunks. Instead of calling it a 4x squared, notice we have a 2x and a 2x. So instead of factoring it using x's, we're factoring it using the 2x's. Notice it looks kind of like what we did before. I can rewrite this now as triangle squared minus 5 times triangle minus 6. Now it looks monic. We took something where the a value was not 1, and now, when we replace out using triangles, the a value is 1. Now this is something that's easily factorable. Can you think of two numbers that multiply to negative 6 and add to negative 5? I believe that would be negative 6 and positive 1. Let's see. The next one we want to do is replace out the triangle. I'm just going to move my work onto the other side so we can see what we did. So remember, triangle in this case was equal to 2x. That's what we replaced. We replaced the 2x with that weird triangle symbol. So we really now have 2x minus 6 times 2x plus 1. But we're not done, because if you multiply that out, you're going to get 4x squared minus 10x minus 6. That's not right. We needed 2x squared minus 5x minus 3. Don't forget that we multiplied by 2 at the beginning. We can't forget that we did that, because now we have to undo that by dividing by 2. So we can't just multiply by 2 and call it a day. We have to now undo that multiply by 2. Which factor is more easily divisible by 2, the 2x minus 6 or the 2x plus 1? I'd rather divide the 2x minus 6 by 2. When we do that, we get x minus 3. We divide each part of that binomial by 2. And then the second part we didn't touch, 2x plus 1. If you multiply x minus 3 times 2x plus 1, you will in fact get 2x squared minus 5x minus 3. If your original quadratic is factorable, this method is foolproof. It will work every time. We just have to be super comfortable with replacing out these chunks here, like a 2x with a triangle, and we have to be super comfortable with replacing it back in at the end and remembering to undo that multiplication at the beginning. If you really, really hate this, another method is just guess and check. You know that your first two terms will have to multiply to a 2x squared, and you know that the last two terms will have to multiply to a negative 3. So you could just play around with the two factors until you get something that when you check it does multiply out correctly to 2x squared minus 5x minus 3. But be careful with guess and check. That might take a long time. And this method right here will work every time, as long as our original quadratic was factorable. Let's do one more example of factoring these non-monic quadratics. And this time, our a value is a little bit scarier than a 2. It's a 6. Think about, what do you want that first term to be? We'd like it to be a perfect square. Instead of a 6x squared, I'd really like it to be a 36x squared, because then I know that 36x squared can easily break apart into 6x times 6x. It doesn't look like that now. We have to multiply the whole quadratic by a 6. What we get is 36x squared minus 30x minus 36. And we can now sort of chunk the first two terms, just like we did before, into a 6x, the quantity squared, minus a 5 times 6x minus 36. Notice how important it is for this piece to match this piece. Otherwise, this whole idea kind of falls apart. If this was a 6x and a 3x, then they're not the same. I can't replace it with a triangle. But now we have this structure, triangle squared minus 5 times triangle minus, let's see, so now two numbers that multiply to negative 36 and add to negative 5. Well, if you think about it for a little bit, you'll know that those two numbers are negative 9 and 4. That's the part of this that unfortunately doesn't go away. We have to have pretty good mental math skills to be able to find those two numbers. And that just comes with practice. But that is something that's unavoidable. We have to really break apart those numbers. So now I can replace triangle. I'm just going to move on to the other side. with the 6x, because if you notice, the 6x was what we replaced with the triangle back in that step. So this becomes 6x minus 9, 6x plus 4. But don't forget, we multiplied by 6 in the beginning, so to undo that, we now have to divide by 6. Something a little bit annoying happens now. I can't divide either factor nicely by 6. So instead of calling it a 6, let's just call it a 3 times 2. Would you agree that 6 is the same as 3 times 2? Hopefully, because it is. Now, notice this first factor is divisible by the 3, and this second factor was divisible by the 2. So we can break it apart like that because of how you would multiply fractions. This is legal. 6x minus 9 over 3 becomes 2x minus 3. Divide each term in that binomial by the 3. And in the second binomial, divide each term by 2, and we get 3x plus 2. If you multiply this out, 2x minus 3 times 3x plus 2, we do get 6x squared minus 5x minus 6 once you combine those middle terms. So this method does work. It takes a little bit of practice because we have to get used to this idea of chunking, replacing with my favorite symbol you've probably realized is the triangle, but feel free to use whatever symbol or other letter you would like. Replacing back in, and then remembering to undo what we did in the beginning. If you're multiplying by something, we have to now go through and divide by it. Don't forget, you can always use guess and check, but it's dangerous. For one like this, I think this would take a long time to factor using guess and check, so just be careful. This method will always work if your original quadratic is factorable. Good luck with factoring non-monic.